so we're going to determine transformations from an equation. We are given the function g of x equals negative 2 times x minus 2 squared. The family, that is basically the parent function of this particular function. And so that is going to be quadratic. And the parent function is f of x equals x squared. Identifying that parent function tells us what we can expect as far as general shape. Then we need to list the transformations in order that need to be performed on the graph to obtain this graph. When we are asked for transformations in order, remember we're looking for RST, right? Reflections, shrinks and stretches, transformations, translations. It's all transformations. All right, so do we have a reflection? Yes, we have that negative 2 out in front. So that negative tells us that we are reflected. And because it is outside, that is going to be a vertical reflection. So vertical reflection tells us that this quadratic is going to open down instead of opening up. Next, we look at that 2. That is a vertical stretch. So that is vertical as well. And it's got a factor of 2. And finally, we have translation. Nothing out on the end. That horizontal shift, so we're going to shift. Negative 2 means we're going to the right. Right 2. Taking all of that into account, we're going to graph this. It says to be very accurate. We're looking for the information. When it says very accurate, that means you need to be able to show this information happened. So shift right 2. So instead of being centered there, we're going to go 1, 2 to the right. So we're going to be there instead. Now we are going to come down instead of up. We go over 1 from there, and then we go down 2. Go back 1, down 2. And there's your graph. All right, so our family of function. This is going to be a square root function. So the parent function is going to be f of x equals the square root of x. Transformations listed in order are S, T. So do we have reflections? No. So we just put none. That 2 tells us we have a vertical stretch. Factor of 2. And then we have 2 translations. We are going to go left 4 and up 5. Left 4, up 5. We start there. Vertical stretch, factor of 2, so we go over 1. Since there's no reflection, we're going up 2. And then we make that kind of check mark look, the swoosh, as my wife calls it, of the square root function. All right, so now we've got a couple of graphs we need to look at that are predetermined. Family, that comes from looking at the general shape. So this is the only graph that we have that has that kind of mountainy look, right? It's not a absolute value. This is definitely a quadratic. As far as what transformations and in what order, right? Remember, we're going to RST. So first, do we have a reflection? Yes, it's opening down instead of up, so that's going to be a vertical reflection. Now we look at the point, right? We start at the 0, 0 point, so that's where the 0, 0 would be. And if I go over 1, I go down 2. So I have a stretch, vertical stretch of 2, and then I look for the center. Where is the center? The center is at the point 3, 5. So right 3, up 5. The equation for this, get these papers out from under that so that I don't accidentally bleed through. All right, so my equation, f of x equals vertical reflection says I need to start with a negative, stretch 2, open parentheses, right 3, so that's going to be x minus 3 squared, and then plus 5 is my up 5. Next one, family. This is my absolute value. What transformations? RST, reflection, vertical reflection. Is there a stretch? I go over 1, down 1. All right, if you look at that, over 1, down 1. So no. Translations, I have gone back 4, up 5. So left 4, up 5. And my equation would be f of x equals negative, because of the reflection, absolute value x left 4 plus 4, up 5 would be plus 5. Now we have another one of these crazy looking little doodads again, and we've just got to kind of figure out what is the equation for it. So if this is f of x, now what we've got to do is see how does each one of these relate back to that original function. Last time I did one of these, I ended up running out of time, so I'm going to put this on a new video.